I'm going to be going over how to solve this related rates problem about how the area outside a circle but inside a square is changing. So, first of all, if you have a moment, pause the video and write down these general steps for solving related rates problems. Step one, you're going to draw a picture and label and identify your variables. Number two, you're going to write an equation for what you're supposed to find. Number three, summarize all of the information that you're given. Four, take the derivative of the equation that you found in step two, usually implicitly with respect to time. And number five, you're going to solve that equation by substituting your given values, which you identified in step three. Now, this may or may not be the exact order that you did in class, but if you look very closely at hopefully your class notes and these notes, you should find that the general things that you have to do are the same. All right, so let's start with step one. Draw a picture and label, and we're going to identify our variables at this time. So you'll notice what we wanted is a circle inside a square. And I haven't labeled it yet, so I'm going to do that with you. Of course, every time we have a circle, we're going to want to label it with our radius, and then it's inside a square, which is helpful and significant because what that means, of course, is that each of the sides of the shape are the same, right? So we have S over there and S over here. Now I have already kind of shaded the area that we want in blue. If you're drawing this picture on your paper, it's a nice idea to kind of shade that what I have the blue area because that's the area that we want to find. And I'm going to also identify the variables I'm going to be using in this problem. So I'm going to let the side of the square be S, the radius of the circle be R, and the area that we want, which is that blue part, be A. All right, so once you draw the picture, then it becomes hopefully a little bit more clear how to write an equation for what you want to find. So I've kind of highlighted the part in the problem that identifies what we want to find. And of course, that is where it says, how fast is the area outside the circle, but inside the square changing? Now, I'm actually just writing it's not a very straight line. I'm just writing an equation for this part, the area outside the circle, but inside the square. And I'm not doing the how fast part yet because how fast is about rates. And to find a rate, we're going to do that when we take the derivative in step four. But I just want to write an equation for the area outside the circle, but inside the square. And of course, that means that we want the area of the square minus the area of the circle. And we can find that by doing s squared minus pi r squared. All right, let's move on and identify or summarize all the information that we're given. We actually already identified the variables. I think I changed the steps a little bit. All right, so I've color coded that kind of information for you. But if you were doing this on a like a test, or if you're doing this in your notebook, it's a good idea to kind of underline maybe the different parts as you're doing it so that you can make sure you've gotten all of the information that you need to get. So we have the radius of the circle is increasing at a rate of ding, 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 rate of per minute. So anytime you see rate or like per minute, both of those are keywords, you know that what you're going to have is something like in this case, radius. So it's going to be dr over dt. So you're taking the derivative of the radius with respect to time. So anytime you see the word rate, or you see per minute, you're going to have something over dt, like that kind of expression. So we have dr over dt equals 1 meter per minute. And then it says the size of the square, all right, are decreasing at a rate of, so I've got few keywords in there, of 5 meters per minute. So again, I have this per minute, I've got the word rate, and also very importantly, I've got the word decreasing. So what that means is, so I know it's ds over dt, I know it's meters per minute, I know it's a rate, but it also means that I have a negative here because it's decreasing. All right, now when the radius is 6 meters, that no rate, right? No per minute. So that just means I have a simple R equals 6 and the size are 15 meters. I have a very simple S equals 15. All right, then how fast is it? Da, 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 da. All right, so but I've kind of summarized all the information that we're given. The how fast is that's the question part, so I don't need that right now. All right, so step 4, this is where we are going to kind of address the how fast part that the question is asking for. And to find how fast something is changing, we do that by taking the derivative implicitly with respect to time. So we have the area equals s squared minus pi r squared. Remember, that's the equation we got in step 2. And we're going to take the derivative of that with respect to time. Implicit differentiation means we're going to be using the chain rule essentially. So we have s squared. So take the derivative. We have 2s times ds over dt. And then remember that pi is not a variable, it's just a constant. So, or it's just a number. So we have 2 times, right, pi r. So 2 pi r, and then times dr over dt. All right. So let's move on to our very last step. Step 5, we're going to solve the equation by just substituting everything that we identified in step 3. So I have rewritten the information for you so we don't have to kind of switch back and forth. But here's our given information. Now, when you substitute, there's no need to also write the units. You can. I find it gets a little bit clunky. So we're just going to substitute the numbers into where they need to go. So we have 2 times s. So s, of course, is 15 meters times ds over dt. That's our -5. Don't forget the negative. Minus 2 pi times r. R is our 6 meters. And then dr over dt, which is 1. Okay, so we're going to substitute all of those values in, and then depending on whether your teacher wants an exact answer or an approximate answer, both of these answers will work. And so what this means is that the area inside the square but outside the circle is changing at around negative 187.7 square meters per minute. Now, a couple of things. Number one, if it's a negative rate, that means that it is, of course, decreasing. So the circle is increasing, but the square is decreasing. So that means that we are right, like that that area outside the circle, but inside the square is decreasing. That's what the negative means. And the last thing is just to be really careful about the units. In the problem, it literally tells you how is the area of how is this area changing at what square meters per minute. So that's your sign. But also, you can know what the correct units are by just thinking about what you're being asked for. So you're being asked for the change in area with respect to time. So minute is a unit of time that we've been using. So you know it's going to be per minute. And then area, of course, is always measured as square something. In this case, square meters, because we're using meters. Hope that was helpful and feel free to reach out if you have any other questions.